Hello students and welcome to Math Weekly number 20, where your focus skill will be applications of the Pythagorean Theorem. The Pythagorean Theorem is a consistent relationship between the side lengths of a right triangle. For any right triangle, the sum of the squares of the two legs is equal to the square of the hypotenuse, as depicted in the picture. A squared plus b squared is c squared. The Pythagorean theorem has two main uses. The first is that it can be used to determine if a triangle is a right triangle by asking yourself, does a squared plus b squared equal c squared? That was last Math Weekly's focus. The second use is to determine a missing side length in a right triangle, and that will be today's focus. We will be either looking for the length of A, B, or C. We're going to begin by looking at how to determine a missing side length with some steps. First step, use the Pythagorean theorem to calculate a missing measurement. You must 1. Label the legs A and B, label the hypotenuse, which is the longest side, C. Second, substitute your known values for A, B, and or C, whichever ones you know. Third, leave the variable for your missing measurement. So if you don't know B, let it be in its place. 4. Solve the equation by using inverse operations. Steps will vary by whether you're finding the smallest, medium, or longest side of a triangle. So what we're going to do next is look at an example of each, missing the smallest, medium, or longest side. Let's begin with finding the length of the longest side, which is called the hypotenuse. So our first step will be to label A, B, and C. For this example, C is already labeled, but if you're not sure which one the C is, use the right angle symbol to draw an arrow, and it will always point to the letter C. A and B can be reversed, but in general, A is the shortest side, B is the medium side. So when we write A squared plus B squared is C squared, we do not know the longest side, which is c squared. That's what we're trying to determine. So let's substitute our known values for a and b. So we'd have 7 squared plus 8 squared equals c squared. 7 squared is 49. 8 squared is 64. So when we add those together, we'll get c squared. If we add 49 and 64 together, we get 113, so 113 equals c squared. Square root both sides of your equation and we get c equals the square root of 113, which we know is a non-perfect square root. So we'll have to determine what it's between. Well, it's between the square root of 100, which is 10, the square root of 121, which is 11, so that makes this 10 and a fraction. The fraction would be the difference between the perfect square root and the non-perfect, which is 13, and the two perfect square roots, which is 21. So 13 over 21. I'm going to go ahead and use our calculator to divide that just to save some time. 13 divide 21, and we get 0.6. So this is 10.6. So the longest side of this triangle is 10.6. Let's now look at an example of finding the shortest side of the triangle, also known as the A side. Again, you can use this right angle to determine that this is the longest side. This is obviously shorter, so it becomes the A, and this is our B. So our equation says that A squared plus B squared is C squared. A we don't know, so we'll leave it say A. B is 12 squared. C is 13 squared. So we have A squared plus 12 squared, which is 144, equals 13 squared, which is 169. To figure out what A is, we need to isolate A squared first by taking away 144 from each side. For 144 minus 144 is 0. A squared plus 0 is A squared. 169 minus 144 is 25. Square root each side, and we get A equals the square root of 25, or A equals 5. So the shortest side of this triangle would have to be 5 units. Let's look at our next example of finding the medium side. So again, we can use the right angle to determine that the longest side is C. B is already labeled, which is the medium side, and the A we know, which is 15. So A squared plus B squared is C squared. So A is 15 squared plus B is the one we know equals C, which is 25 squared. So we start by simplifying our numeric expressions. 15 times 15 is 225 plus b squared because we don't know what b is, and 25 times 25 is 625. We again need to isolate b squared by taking away 225 from each side. 225 minus 225 makes 0. 0 plus b squared is b squared equals 400. Square root each side. So b equals the square root of 400. So b equals 20 because 20 times 20 is 400. So this medium side would have to be 20 units. Okay, let's look at a context which requires us to do two steps. The question says, how many units long is segment AB? Well, if you look at segment AB, it is part of this right triangle. But in this right triangle, we only know one measurement. We cannot use the Pythagorean theorem if we only know one measurement. We need to know two to determine the third. But do you see how this height of triangle ABD, the one that's the AB is a part of, is also part of triangle BCD right here. So we'll have to do the Pythagorean theorem twice. Once with triangle BCD and 5 and 3 to determine this height, and then again with this triangle to determine what segment AB is. Okay, so I'm going to label our first part to determine segment BD. And I'm writing that because I want to remind myself that's not what I'm looking for, just part of the process. So if I hone in on BCD's triangle, I'll see that the right angle points to the longest side of C, 3 is the shortest, and segment BD, the one that we don't know, is the medium side. So I'm going to write A squared plus B squared is C squared. A is 3, so that's 3 squared, plus B squared we don't know, equals 5 squared because that's the value of C. 3 squared is 9, plus b squared is 5 squared, which is 25. Take away 9 from each side. 9 minus 9 is 0. 0 plus b squared is b squared. 25 minus 9 is 16. Square root each side. And b equals the square root of 16, or b equals 4. So now we know that b is 4. Now we know 2 out of the 3 sides that contain segment AB in triangle ABD. So let's work on determining segment AB. So again, we're going to be using the Pythagorean theorem because this is a right triangle as depicted here. If this side's 90 and it makes a straight line, then this side has to be 90. Now, before 4 was our B, but now 4 is our A because it's shorter than 7. The side that we don't know is our C, and our B is 7 because it's the medium side. So I have A squared plus B squared is C squared. I have 4 squared plus 7 squared equals C squared. 4 squared is 16 plus 7 squared is 49 equals C squared. Add 16 and 49, which makes 65. So 65 is equal to C squared. Square root each side, and C equals the square root of 65. Now we know that the square root of 65 is not a perfect square root, so we have to figure out what it's between. It's between the square root of 64, which is 8, and the square root of 81, which is 9. So this is 8 in a fraction. It's only 1 away from the first perfect square root, and the two non-perfect square roots are 17 away from each other. So we have our fraction of 8 and 1/17. I'm going to go ahead and use the calculator to divide that, but I'm guessing it's going to be 0.1, or maybe not even that. Yeah, so the 5 will round it up to 0.1. So this is 8.1. So the length of segment AB is approximately 8.1 units because it doesn't say whether it's centimeters or meters. So let's summarize what we've learned about the Pythagorean theorem. The Pythagorean theorem states a consistent relationship between the three sides of a right triangle. In the formula, a squared plus b squared equals c squared, a and b are the lengths of the legs of the triangle, and c must always be the length of the hypotenuse. The Pythagorean theorem has two uses. The first, determine if a triangle is a right triangle, and second, calculate a missing side length for a right triangle.